Good morning. So today, anywho, we're going to be learning about the chapter 2.1 for stats. And basically this encompasses 4 principles, which is percentile, relative cumulative frequency graph, or the ogive, the z-score, and the plus minus division and multiplication by constant and the effects that it has. So the easiest way to describe a percentile is trying to find the location of a certain number in a data set. So here we have 15 numbers, and say we're trying to find, the location of 84 within those numbers. Now for percentile, it's really easy. So all you have to do is you have to do how many numbers you have in total, so that's 15. So you kind of set like not a proportion, but you know what I'm talking about. Anywho, you set that. And so you count the amount of numbers before 84. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. There's 12 numbers before 84. So 12 over 15 equals, well, I have to do math. Okay, so after my little math, you kind of find out where it is. And so it's in the 80th percentile. So basically, to remember for percentiles, is all you have to do is know how many numbers are in the data set, and then you need to know the specific number or position in which you need to find the percentile for, and you count up until then, and you put it over the total to equal the percentile. So it's really easy. It's nothing to fret about. So basically, it's 2 parts, and so to find the relative cumulative frequency graph, you look at the data, and so I kind of made my own. It's so height of trees in feet, and it's in like a range, so 10 to 20 feet and 21 to 30 feet, etc., and the frequency. So the first thing you have to do is calculate. So we have a total of 20, so 6 over 20 equals 0.3, and what you do with this is you multiply it by 100 in order to get a percentage, or the frequency, which is what will be the y-axis of our graph. So it's 30%. And you do that for all of these. And so to kind of make it nice and brief, what you do is you graph it, and and this is basically, it has this shape, which it like slowly increases. But what you can do is, so if you want to find, the number and what percentile it'd be, so say it'd be like, whatever you call it, like 35 or something like that. So you go up in the middle, and you keep going, and it hits here, and then you go across, and you'd be able to find what, percentile it would be. That's the purpose of this graph. So basically, the purpose of this graph for the cumulative relative frequency is, to graph it, it'll have like this nice little shape where it slowly increases. Where if you were to go to a number like, say, 50, and you want to see the percentile, you would shoot up, and then you would go straight over, and you would estimate what it is, that was a very bad line. But this isn't necessarily the most accurate graph, and I'm going to try and draw that for you. But basically, in order to really graph it, all you have to do is, so you have the lovely, sorry, wrong one. You have the lovely, not margins, but like the intervals, right? So 10 to 20 feet, 21 to 30 feet, and whatnot. So you have all that. Well, basically, what you need to do is you need to take the frequency that you've calculated for one, and you need to graph it for the next lowest part of the other interval. So for at 21, you graph 30 percentile. So let's see, right about here, and then the 30 percentile, so it'll be here. And then for the next one, you graph and continue graphing. So that's how you do it to be accurate, but that's where you would start. Now, for the z-score, which is actually really, really easy, to kind of make it short and easy for a brief explanation, part of statistics is finding the probability of something. But in order to find the probability, which is on a z-score chart, you have to find the z-score. And now what you do is you have a certain problem where you have like a mean, and then you have the standard deviation, but you have the, a certain number, and then you try and calculate what the z-score is. And that doesn't make much sense, but it's going to make sense in a little bit. So the formula is x minus mean over standard deviation. That's supposed to be an n. Okay, can't spell. Anywho, Coach Camp would want it to be standard deviation because, well, if you don't spell it out, then you may not know, blah, 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 blah. And now mean can be interchangeable for x bar or mu, or depending on what the problem calls for. And I'm going to show you a real life problem and how to work it and make it nice and easy for you. So the problem is a recently diagnosed patient with Alzheimer's takes a cognitive test. Their score was a 45 with a mean of 52 and a standard deviation of 5. So what is the z-score? And to set that up, you do 45 minus 52 over 5. And so this is negative 7 over 5, which equals... And the answer is negative 1.4. And so what you would do is you would look at the z-score chart, which is another lesson. But what you do is you go to negative 1.4. And since it's negative 1.4 exactly, so it'd be like negative 1.40, you go down to negative 1.4 and you go over one column because it'd equal this value. And then you would find the probability. Now what matters is if, say, it's a z is greater than blah, 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 blah. Then that's when you do 1 minus what you got for the p-value in order to get the real p-value, if that makes sense. Because of the way the graph is made and whatnot, that's how you do it. And that's the z-score. And it's pretty simple, so don't overcomplicate it. Thank you. And now, just to show you when you graph it, it's a nice little curve. I forgot that little hump. And so you graphed it because it's negative 1.4. And so the answer for the p-value would be 0.0808. And for the z-score, you want to round approximately to 2 decimal places to find the p-value. And the p-value you round to 4 places. So you would just shade this in, and that would be what you would do for graphing. Well, Coach Kemp, it's going to be over 7 minutes, but you know what? It's thorough. So anywho, to get back to the point, the effects of adding, subtracting, multiplying, and dividing on a constant, you got to learn a few things. So cus and BS. Ignore the BS, the B specific. The cus is the center, shape, spread, and then U is the uniqueness, whatever. But the 3 most important things is the center, shape, and spread, because you got to determine what your graph is going to look like. And so you have all your data points and you do a dot plot, and once you graph it, you kind of study it. And so you look at the median, you find the middle number. And then for the shape, is it skewed to the right, is it skewed to the left, or is it unimodal and pretty symmetrical in that sense? And then for the spread, the box and whisker plots that we would have, where you graph the lowest number, the highest number, the middle number, and then the numbers in between, by finding it, and stuff, elementary stuff or middle school stuff. Well, you have that. So the spread is the Q1 and the Q3, and so that's the Q1 and the Q3, or the interquartile range, IQR, is about 50%. Actually, it is exactly 50% of the data. And so you need to know all of this in order to know and understand the effects of the constant. So to sum it up, to make this video under 10 minutes, which hopefully it's under 9, but when you add and subtract by the same number, which can be positive, 0, or negative, in terms of number, you add that number to the center and location, so the mean, median, quartiles, and percentiles, but it doesn't affect the shape of the distribution or the measures of spread, which is range, IQR, and a standard deviation. And the reason for that is because it kind of makes sense. So it doesn't change the shape because you're basically just moving the points, but you're moving every single point equally. So it's not like, oh, I'm going to choose the Q3 and move it this way, and you're going to jack up all of the shape, but instead you're moving it all maybe by like 3 points, adding 3, so it's just kind of shifting over in a sense, if that makes sense. And I forgot to mention that for the adding and subtracting, the number in which you add and subtract is referred to as A, and it's a lowercase a. And then for when you multiply and divide, it's referred to as A, lowercase b. And so if you multiply or divide by the same number, aka b, it's either positive, negative, 0, just like, up here, the measures of center and locations of mean, median, quartiles, and percentiles by b, multiplies and divides measures of spread, range, IQR, and but it does not change the shape of the distribution. So it's very similar to this, and so as a review, it says if you add and subtract that number to center and location, the mean, median, quartiles, percentiles, it does not change shape of distribution or measures of spread, range, IQRS, standard deviation, but with multiplying and dividing by b, measures of center and location are multiplied by b, mean, median, quartiles, percentiles, and it does also not change the shape of the distribution. I think the biggest thing to know is that when you add and subtract, like, it doesn't change the shape of the distribution or measures of spread, which is range, IQR, standard deviation. But with here, the big significant difference is that it multiplies or divides measures of spread, which is range, IQR, standard deviation, by b. So that's the big difference. This part right here doesn't change necessarily, but this part does. So just remember, how multiplication and division is more complex. It's more complex in the sense of range, IQR, and that stuff when it comes to being affected by, certain constants, if that makes sense. So to conclude, I would just like to leave you this lovely message. Thank you for your time and consideration.